everyone. This will be the next section of material calculus. So whatever I covered before that was like that was the section before the first quiz, and so now I'll just be like doing the stuff after that. So it's mainly like this open set, closed set definitions. There's like continuity, limits, all that, and then there's partial differentiation. So I'm just going to start straight up from this chapter. So I think this is called, okay, this is limits and continuity in higher dimensions. We don't require that. We are going to start like straight up from like the first exercise. So it's partial derivatives. We're building up to the notion of Lagrange multipliers eventually. Right. Okay, so first is just like level curves, a set of points in the plane, whatever. We're just going to skip all of this. No need for examples or anything. We're just going to start with exercise 1.1. So find the specific function values. Sure. So f of x is just this stuff. I mean, okay, this is bullshit. This is like it's childish stuff. I'm not going to do any of that. But yeah, just like mentally, if you had to do it, 0, 0 is just 0 over there. This thing minus 1, comma 1, it's like 1, and then this thing is minus 1 is 0. At 2, comma 3, this is like 4 plus 2 times of 27, so that's 54. 54 plus 4 is 58. This is like what, 9, 9 plus, so 9 minus 2, so 9 minus 3 times of minus 2 cube, so it's like 9 plus 3 times of 8, which is 9 plus 24, so that's 33. Then this is sine of xy, so just 2 times of that, so it's like pi by 3, sine of that is 1 by 2. This thing is minus pi by 4, so negative 1 by square root 2. This thing is once again 1 by square root of 2. This thing is minus 7 pi by 2, which is like minus so that's like 8 minus 1, so that would be like 4 pi minus pi by 2, if I'm correct. Yeah, I mean, you can just add 8 pi by 2 directly, so it just becomes, oh, it actually plus 7, so sure, so it just becomes minus pi by 2, right? Yeah, I mean 7 pi by 2, or you could just do like 6 pi plus pi by 2, so it's just 3 pi plus pi by 2, which would be like, so the 2 pi gets, so it's like pi plus pi by 2. It's a sine of that, so it's negative 1. This stuff, x minus y, that's 4 upon 1 plus 4, that's 5, whatever. So you get the basic feel of it. All of this is like just bullshit. So yeah, okay, find and sketch the domain for each function. So you got, so the domain, that's sort of nice. So square root of y minus x minus 2, so it just has to be greater than or equal to 0, so that you can take the square root of that. So what we require is like y is bigger than or equal to x plus 2, so basically just a line like this. So it's x plus 2, everything above that, that's the domain. For this one, natural log of x plus this stuff, it has to be greater than or equal to 0 as usual, so x squared plus y squared should be bigger than or equal to 4. Not in fact even equal to, it's actually just bigger, so this thing is an open set, and something like this. So we'll come to the definition of open and closed. This is an unbounded open set, by the way. Okay, anyway, then what we have is this function, so only the y equal to x and y equal to x cube points are of interest because those are problematic. So the y equal to x line should not be there, but so this curve y equal to x cube, this should also, so by the way, the derivative is like 0 at this point, so it's something like this. At x equal to 1, this will intersect. So anything other than these curves, it's a valid point, right? So these are not involved, but everything around is involved. So this is also an open set. Okay. F of x equal to sine of xy upon x square plus y square minus 25. So once again the same stuff, that x square plus y square minus 25, that should not be 0. So what should not happen is you shouldn't lie on this circle. Apart from that, everything is good. So this is the circle with radius 5 centered around 0. So it's once again an open unbounded set. You get that stuff, right? So it's cosine inverse of y minus x square. The same stuff, y minus x square should lie in minus 1 to 1. This which means minus 1 to 1. So basically like y lies in x square minus 1 to x square plus 1. Alright, so if I draw these two curves. So x square looks something like this, and then so this is like 1 and 1. For 2 this would be just 4, something like that. It's going to be like somewhere over there, maybe over here, it's here and then there. So this is x square, so we want x square plus 1. That would look something like, just going to bring that down. So yeah, okay, cool. So we want x square plus 1, so it's going to start over there. So it's going to look something like this. Yeah, and x square minus 1 would look something like this. So at x equal to 1, something like 0. So this is supposed to be 0 over here, I suppose. So this is something like this. Okay, so what should happen is, where was I? What was I doing? There's some x square stuff involved. Where did it go? Yeah, right. It's cosine inverse of y minus of x square. So this should be between negative 1 to 1. So yeah, y should just be in this range. So it's all of this region. And this is an unbounded but closed region. There is no open like stuff anywhere. You don't have a, you have a boundary, right? So it's not open. Basically an open set is just something which doesn't have a boundary point. A boundary point is anything where no matter how small you make a disk around that point, you'll always have like regions which are in the set and outside the set. So for example, something over here is a boundary point, because no matter how small you make a disk around it, you will have area from here and from here, both. So yeah, okay. So since this contains boundary points, this is not an open region. Anyway, what was I doing? Natural log of x plus y minus x minus. So you can factorize that. It just becomes like x times of y plus 1 minus 1 times of y plus 1. So it's just x minus 1 y plus 1. So what we want is just natural log of this stuff. So this should be positive. You can't just break and say that each of the individual things should be positive, because that's not how it works. So this should be greater than or equal to, if not even equal to, it should just be strictly greater than 0. So for that to happen, you have a bunch of cases. Either you have x is bigger than 1 and y is bigger than minus 1, or x is smaller than 1, right? So that x minus 1 would be less than 0, and then y is smaller than minus 1, right? So you have these two regions. First is x is bigger than 1, which is this, and y is bigger than minus 1, so it's this. So it's this open region, this stuff, and then you have the both being less stuff, so it's these regions. Okay, next we have square root of x squared minus 4 y squared minus 9. So once again, this is just greater than 0 or equal to 0. That's the thing. So yeah, it's just a bunch of things. So what we require is like x square should be greater than 4 and y square should be greater than 9, or x square should be less than 4 and y square should be less than 9. Both should happen pretty much. So this region, x square is greater than 4 and y square is greater than 9. What does that mean? This means like x is bigger than 2 or less than minus 2. This would be like 2, this would be minus 2, this would be like 3, this would be minus 3. So either this or that, and at the same time you should also have this. So this whole region is what we are looking for, right? And then you also have this region where x is less than 2, yeah, and then so basically this inside stuff, that's one region. So the only problem is when, hey, wait a second, y is less than 3. Okay, oh, okay, I see. Something is problematic with this. Yeah, so that would be the thing, and that would be the thing. I see. So it's this region actually. Sorry for that. These 4 quadrants. Right. So that's the first region, and then the second region is just this stuff. Okay, that makes sense. Next is natural log of this. So once again, this has to be positive, so what we require is 4 is strictly bigger than x square plus y square. Moreover, this thing cannot be 0, so you also cannot have 4 minus x square minus y square equal to 1. So yeah, this should not be equal to 1. So what you cannot have is like x square plus y square is equal to 3. You cannot have that. So this circle, so this is like 4, this is 3. This is not included in our region, and everything inside of this is actually included except for this line. Let's hope that actually makes sense, but yeah, whatever. Okay, next. Find and sketch the level curves on the same set of coordinate axes for the given value of c. We refer to this level curve as counter maps. So for example, x plus y minus 1, what would a level curve for that look like? So it's let's just say start with minus 1 as the value, then switches to like x plus y equal to 0, which means x equal to minus 1 or something like that. So that would just be this. Then you would have so this is for z equal to minus 1, then for z equal to 0 you just have this region. Yeah, so it should be 1 over there. So this is 1, this thing is 1, right? Because x plus y should be equal to 1 in that case. And then so this is for z equal to 0, then for z equal to 1 you would have this region where this is 2 and so on. This is 3, and yeah, this is our level curve. Right. So as you can see, it's getting higher and higher now, right? So if this is a, like if you had to shade this or something, and let's just say that lower values are shaded as darker, so then this would be shaded slightly darker, and this would be shaded slightly darker, and this would actually be shaded much darker in fact, because yeah, so something like that. It's going up, if that makes any sense. Anyway, next is x square plus y square. That's our function. That's actually pretty easy to do. So 0 z equal to 1 is just like this circle, z equal to 2 is this circle, z equal to stuff like that. Actually no, z equal to 1 is this circle, z equal to 2 is, so x square plus y square equal to square root of 2. So you don't just do that actually. So this would be for 1. Square root of 2 is something like 1.4, and the square root of 3 is 1.7, so it's something like that. So it would be this circle, then it would be this circle, then it would be this circle. So it's pretty close to 2 now because it's 3. Then it would be just the 2 circle, right? Okay, that's not important. Okay, this is probably how it should be drawn. Anyway, and then for the next point, which is what, 4 it's done. For 5 it's like 2.25 or something, so it's even closer now. So it's just going to be like smaller and smaller width as you keep going. So this is how it's going to be, right? So this width keeps decreasing, but yeah, it's like an infinitum of this. Anyway, next, so c is okay, fine, the z values, sure. So we did for 0, 1, 4. Why should I do it for z equal to 4? No, I won't do it. If I want to show like the correct variation, I'll do it for z equal to 0, 1, 2, 3, 4, so on. Not for 0, 1, 4 and so on, because what that would look like is something like this: 0, 1, 2, 4, 9, so on, right? And that does not give us like a good, what do we say, description of like what this is. So I'm not gonna do that, like, unless stated. It is stated, okay, whatever. Next we have xy, so z equal to minus, okay, this is once again going towards the same territory which I don't want it to go into, that you are making the curves, the level curves, the equidistant, but you're not making them have the same distance between the z values, which is not how it should be. Like, look at these curves. Do you think that you just make these equidistant? No, you don't. Anyway, so for minus 9, when one of them is 3, the other one should be minus 3. So 3 comma, it's going to be like 1, 2, 3, 1, 2, and then 3. Yes, I know this is probably not how it should be done, but whatever. So 3 comma minus 3, something like that. It's just a hyperbola, so it's something like 3, Anyway, so that's 3 comma minus 3. So minus 9. Then, oh, sorry, that's actually plus 9. But sure, whatever, it doesn't really matter. That's plus 9. And for 4, it would just be 2. So, do this stuff. Something like that. For 1, it would be just this stuff. Right. For minus 1, it would be this stuff. Oh, by the way, it's not just over here, you should also have it over here. So these are the same sort of things, right? It's just this hyperbola. I don't know, this is like really bad drawing, but yeah, whatever, don't judge me on that. I mean, I draw good, it's just I don't draw when I'm in a hurry. Okay, so these are the same, so like this and this both are part of the same level curve. I don't know if that makes any sense, like seeing it like this, but yeah. So this is 1, this stuff is for 2, this stuff is for 3, right? And then similarly you would have something over here, so it would just be like that. And for 2 just have this, and for 3 we just have this, and something like that. So this is how it should look pretty much. Anyway, move on. So I'm just gonna delete all of this. Anyway, so next we want 25 minus x minus y square, the level curve for that. I just don't want to be doing this. Yeah, I just don't want to be doing this. Move on. Not gonna be doing this stuff. Find the function's domain, the function's range, describe its level curves, find the boundary of the function's domain. Find if the domain is an open region, closed region, neither. Yeah, if the domain is bounded, unbounded. Okay, this is actually a good question because you have to figure out a lot of stuff. So basically we just talk about the domain. So domain and range both are like easy to figure out. For example, for y minus x, it's all R2, so whole of R2, so it's an unbounded open and closed region. Yeah, R2 is open and closed at the same time. It's weird, but that's because closed has a different definition. It's not just the inverse of open. Okay, what about its range? Its range is also just all of R, so it's, I don't know, I don't want to be describing that because you don't have to. Okay, remind if the domain is open region, closed region, neither. What do you mean neither? It can be both as well, by the way. Okay, 18th is f of x xy equal to square root of y minus x, so everything that's like y minus x is greater than or equal to 0 is okay. So it's a closed, it's not open. Firstly, is it closed? Yes, it is actually closed. So it's a closed region, but it's unbounded, right? It's closed because any sequence of points, if it converges to a point, that point is also in your range, sorry, in your domain. What about the range? The range is, it can be 0 and it can be anything positive. So like all of R plus or R bigger than or equal to 0, that's probably the better way. Okay, so that is a closed set. At the same time, it's unbounded. That is very weird, but whatever. Decide if the domain is bounded or unbounded. We did that. If x equal to 4x plus y square, all of R2 is the domain, so it's like an unbounded closed open region, and the range is everything that's like R greater than or equal to 0. So it's a closed, it's not open by the way, so it's just a closed unbounded region. What about this one, x minus y square? Oh, this is okay-ish, like you can have anything built up with that. So all of R2 as a domain, and the range is all of R as well. So yeah. Okay. Oh god, are you serious? xy, amazing. All of R2 as a domain, all of R is the range, because you set y equal to 1 and you get all of R. Y upon x square, the domain is slightly different. So you can't have x equal to 0. Everything else is doable. So it's an open, it's not closed. Sorry, yeah, it's an open. It's not closed firstly. Open, unbounded region, sure. And the range is just all of R. So okay, f of xy equal to 1 upon square root of 16 minus x minus y square. So what should happen is like 16 minus x minus y square. This thing should be positive, not equal to 0. like that shouldn't be included because the 1 upon stuff. What that means is like x square plus y square should be less than 16, so it's just this region, this disk sort of a thing. It's an open bounded, right? It's not closed, by the way. You have a sequence of points like this and it doesn't converge to something in the set, right? So it's an open bounded region. Yeah. What about this one, square root of 9 minus x square minus y square? This is an open closed, sorry, it's not open firstly, it's a closed, I mean, yeah, right, x plus y square should just be less than or equal to 9. So it's a closed bounded region. This one, let's look at x square plus y square. So x square plus y square should be positive. It's the only restriction. It cannot be 0. So, okay, x square plus y square should just be greater than, not equal to, just greater than 0, which it is most of the times. So the only condition where it would be 0 is if x equal to 0 and y equal to 0. So it's everything except the 0, 0 point. Basically, it's p squared, the projective. Never mind. I shouldn't probably talk about this. Because that's actually in like 3 coordinates. It's like p1. Who am I kidding? Why should I talk about this? So the thing is, x plus y square is greater than 0. That's an open set, because so around 0, 0, right? You take a point. No matter how small of a disk you have, you can always have like a smaller disk and say, oh, but everything over here that was actually in like inside of this disk. So by contradiction, you can say that, oh, 0, 0 is a boundary. Like it will never be a boundary point or something like that. Okay, I shouldn't say that. Yeah, I mean, so there exists one point where this like doesn't hold true. Like no matter how small of a disk you do, you still have that stuff happening. So wait, what does that mean? Is it open? No, it's not, right? Because there's a point such that no matter how small of a disk you take, you're going to have that. So is 0, 0 a boundary point? So it's everything minus 0, 0. Okay. Wait, is this thing, is this open or not? Actually, I'm going to search that up. So is R2 minus the set with 0, is it open? So right, so is this open? So for each xy which is not 0, 0 in R2, the open ball of radius x plus y square centered at xy does not contain the origin. Right, so the disk, you can shrink that a bit, right? And then just say, okay, cool. So for everything inside of the region, this does happen, right? Yeah, so a set containing a boundary points that would, right? So this is a boundary point. 0, 0 is a boundary point, but it isn't in the region. Like it isn't in the set, and thus, even though it contains it has a boundary point, it does not contain it. So it's an open region. Right, that's very weird. Is it closed? No, it's not closed, because a sequence you can make it go to 0, 0, but that thing wouldn't be there. This is frankly a bit bizarre, but hey, that's just how it is. Okay, so next is, what are they doing exactly? Oh yeah, the natural log of x square plus y square. Then you have e power negative x square plus y square. So anything, like put it, it's okay. So it's all of R2, and the range is, it can never be 0, so it's just exclusive of 0 to infinity, right? It can go to infinity, I suppose, because, hey, can it? No, it can't, right? The worst it can be is like if this is 0, 0, so that's just like 1, so 0 to 1, that's the region. So it's not open, because 1 is a boundary point, it's contained inside of the region, so it cannot be open. So is it closed? No, because 0 is contained in this, so it can never be closed, because 0 is not contained, even though it's a limiting point, right? Even though it's a boundary point or something. So what does that mean? It just means it's neither open nor closed. It's a bounded, just a bounded region, something like that. Okay, fine. So it's like open at one end, closed at other, so that's why. Anyway, next. Next is sine inverse of y minus x. Oh, also you should probably also go for this stuff, but it's okay. All of R is allowed. So okay, sine inverse of y minus x. So the same as the before, right? So y minus x should be in minus 1 to 1 inclusive. So what does that mean? That y should be in x minus 1 to x plus 1. So it's just some region like this. Yeah, like that's the thing. So it's a closed region. It's not bounded anymore. It's definitely not open. It contains lots of boundary points. So yeah, that's it. This is a closed unbounded region. That's our domain. What about the output? So the worst case is when you have minus 1 and 1. It's okay. So it's just minus pi to pi inclusive of both, I think. Right? Is it? Hey, what's the okay? It's minus pi by 2 to pi by 2. Minus pi by 2 is like minus 1. Pi by 2 is plus 1. So everything's included. So it's okay. It's just a closed region. Whatever. Tan inverse. Yes, this is where stuff gets problematic. So it's minus. No, it's actually this is also okay, right? Hey, so is minus pi by 2 inside of the range? It will never be achieved. So it's not like it can be, right? So what's theoretically the range of tan inverse? Yeah, it's an open interval. Which makes sense because range is defined as the set of all points that your function maps to. So it can never map to minus pi by 2 because there's no point which it will map to. It's negative infinity which it maps to minus pi by 2. But that is not a point, that's a concept. So okay, that makes sense. Y by x, you can never have x equal to 0. That's kind of why you can't have minus infinity. What does this mean? Your domain is everything where x is not equal to 0. So it's just its boundary point is wherever like x equal to 0. It's a boundary point, of course, but it does not contain any of these. So it's an open region. At the same time, so it's not closed because x equal to 0 points are limiting points in here. So okay, it's not closed. It's an open, unbounded region. Okay, and then tan inverse, the range of that is it's this thing. It's pi by 2 to pi by 2. So yeah, sure, it's just an open bounded region. What about this natural log of x plus y square minus 1? So just as any kind, just natural logs range, that's it. And x plus y square minus 1 should be positive, so x plus y square is bigger than 1, so it's an open unbounded region. Okay, similarly over here, this is a bounded open region. Okay, matching surfaces with level curves. I'm not interested. Okay. What is this? Like, what am I supposed to do with these things? So A to F on the following page. Appropriate function. What appropriate function? What are you talking about? I don't know, I don't see any functions. Anyway, functions of two variables display the value of the functions in two ways: by sketching the surface, by drawing an assortment of level curves in the functions domain. So sketching the surface is kind of complicated. Z equal to f of x, y, I don't know how to properly sketch surfaces actually. Assortment of level curves in the functions domain. Label each level curve with its function value. So I suppose the best way to sketch like surfaces is just to actually like draw a lot of points and then join them. So for example, if you had f of x y equal to y square, so basically z equal to f of x y is what you want to do. So what you would do is, so this is your, let's say the x-axis, this is your y-axis, and this is your z-axis. Then y square would be like, so at So let's say z equal to 0. For that, y has to be equal to 0. So that's this point. It's one of the level curves. For z equal to 1, you would have your y equal to 1, so it will be this point, and then it's like, so it doesn't actually matter. So that's it, that's the whole point. Or minus 1. Okay, and x can be anything, so it's just, this is your level curve. Okay, I don't even know if this should be called a curve. Anyway, so it's just going like this, it seems. I mean, okay, not like this, but like this. So at z equal to 2, I would, yeah, so at z equal to 2, you would just have something like this. So it's, this thing is 1, this thing is 1.4, this thing is 1.7, this thing is probably 1, right? Okay, this is 1.4, this is 1.7, so be at z equal to 3, and so on. So yeah, this is probably how it should look. So this is the parabola in the yz plane, and so what's happening is that these are the level curves. So just have this, and then this. So I'll have to shade this, otherwise it just doesn't look like, it doesn't make sense. So this would be all like shaded like this, and this would be shaded slightly darker, right? Yeah, this is how it should be most likely. Oof. Okay, something like that. This is some artistry that I'll have to do in the time of exam. This is not making sense. Like, why should I be doing this stuff? But sure, just move on. Okay, next we have, this is just y squared. It's not even a complicated function. Just think about what's going to happen. So then you have this. This is the x, this is the y axis, the z axis. So the exit plane, now you have this thing, square root of x. So as your x is going like this, it's now go like that. Yeah, this is how it looks. And so for z equal to 1, so actually just make a bunch of points first. This would be z equal to 1, right? And so on. So no, okay, at z equal to 2, you need to have x equal to 4. So 1, 2, 3, this is 4. So it's like this. Yeah. So your curve would look something like this. This is 1. This is the other level curve, right? So y can be anything, but your x is fixed now. And then you would just go like that, and this would be like 9. Wherever you hit that, that's another level curve. Sure. So then, like shading that, you would get your actual thing. I suppose, yeah, this actually makes sense. Anyway, just move on. Then you have, so what's a level curve versus what's a level assortment curve? Okay, it's just not giving me the answer. So, oh, okay, right, sorry. Assortment of level curves. Level curves is like this in XY, and then functions domain, and the surface. The surface is actually what we are kind of sketching. But anyway, so you did square root of x. You also want to do x square plus y square. So you can draw the level curves pretty easily. But then when it comes to the surface, this just becomes a whole lot messier. So this is the z equal to 1. It's going to be like I don't know, this is just more of like engineering graphic stuff rather than some actual thing. So z equal to 2, it's going to be like 1.4. Somewhere over here. Oof. This is just I don't know what I'm doing. I just really don't know. Okay, so that's what the surface looks like. It's something like this. Okay, wow, this is bad. But anyway, so I'm just gonna draw like this part. This is z equal to 3 would be something like this. Right. Anyway, so this is how the graph should be for different of these level curves. So I'm just gonna shade all of this and then say, oh, this is slightly darker because it's lower values. This is even darker because lower values, and this is even darker because lower values. Yeah, that's the way to think about it. Anyway, this is just really bad. Like, I don't want to actually think about it. Anyway, move on. Just this is good. I mean, I'm getting some practice out of it, but it's just like not really useful. Just gonna move on. Okay. Finding level curves. Find an equation and sketch the graphs of the level curves. I don't want to do this. What about this one? This looks hard. So it's 2x minus y upon x plus y plus 1. So if you just have z equal to this, what can you do with this? Oh, so passes through a given point. So it will just be like, oh, come on. Then it's easy. Then what's even the point? It's just minus 1 minus 1. It's like minus 1. Wow, it's just minus 2 and plus 1. This is equal to 1. That's what we are saying. So it's x plus y plus 1 equal to 2y minus x. Amazing. What do you have? You have y minus 2x minus 1 equal to 0. So y equal to 2x plus 1. This is like a basic sort of a thing. Like, seriously, just look at this. It doesn't make sense. Why would you make me do this? Move on. Sketch a typical level curve. I won't. I just won't. I'm moving beyond this. Okay. Sketch the domain of f. Then find an equation for the level curve or surface of the function passing through the given point. So first is like this summation 0 to infinity of x by y power n. So x by y is just some r. So it's going to be like 1 upon 1 minus r. Only if your r is less than magnitude is less than 1, right? The radius of the radius of convergence and all that. It's usually for complex numbers, but then whatever. So all you have is like x by y that should be less than or equal to 1, bigger than or equal to minus 1, something like that. So what you really have is like x should be less than or equal to y and bigger than or equal to minus 1. Yeah, so for a given y this should happen. For y equal to 0, you don't do that because it's undefined. So yeah. the domain is just everything where y is not 0, so it's all xy such that y is not equal to 0. Next, the other rule is like x is in this range, and yeah, I mean that's pretty much the only rule. You don't need to have anything more, like, yeah. Oh wait, what do you want to do exactly? Oh, so given a point, find and sketch the domain of f. Then, so okay, this is the domain. You should be sketching that. Okay, it's not a bad idea. So for different y values, you have different ranges of x. So for y equal to 1, you just have 1 and minus 1. So the whole point will be something like this. So y equal to 0, just have that. Right. Y equal to -1, just be this. So this is the range. Now of course 0, 0 is not allowed, so this point is not there. And this is there, this is closed, sure. So this is open because one of the boundary points, which is 0, 0, it's not there, right? Yeah. Cool, this is fine. Find an equation for the level curve or surface of the function passing through the given point. So it's 1 comma 2, so all you have is like 1 upon 1 minus so what you really want is something like 1 upon 1 minus x by y. It should be equal to 1 upon, just wait a second. Anyway, so we just had x by y is equal to 1 by 2, so it's just 1 minus 1 by 2. So we just have x by y equal to 1 by 2, that's it, it's just 2x equal to y. So y equal to 2x, that's just this line. 2x, which is this stuff. Sure. Cool. So this is okay, I suppose. Okay, next. G is this. Find an expression, sorry, equation for the level curve. So this is just another summation. So you're just making it more complicated, that's it. Like you're not actually changing the thing. So it's x plus y power n upon, so x plus y upon z to the power of n, 1 upon n factorial. This is a very well known thing. It's basically the e power stuff. So this is defined to be exponential of x plus y upon z, whatever this number is. So this number, it just has to be defined, and that's pretty much it, because e power x has infinity as its radius of curvature, the radius of convergence. Yeah. Okay. So its whole domain thing is just like everything x y z. So like all R3 except that z should not be 0. So it's like all x y z such that z is not equal to 0. Yeah, and it's like what? It's a 3 variable thing. Yeah. So what you have is like e power, so exponential of x plus y by z. This should be equal to the exponential of h log of 1, h log of 9 upon 2. So this is h log of 2 and 3. So this is 6 pretty much. That's our curve. Next thing, so this is all easy, like there's no hurdle in any of this. This integration is easy to do. Just put theta as sine something, sine phi. Yeah, sure. From x to y. So first thing is that this should be defined everywhere, because otherwise it just doesn't make sense. So theta cannot be 0 at any point. So you shouldn't have -1 or 1 in any case. So what should happen is that your -1 shouldn't be there. So yeah, okay, you might have a bunch of cases. So when will the -1 thing be there? When your x is less than -1 and y is more than -1. So the conditions where this doesn't really mess up is this is -1 to 1. So you just have x over here, y equal to here. So it's y less than or equal to minus 1 and x is less than or equal to that. That's one thing. And obviously x has to less than or equal to y, because otherwise this just becomes some bizarre stuff. Actually, no, you don't have to have that. You can always reverse the thing, right? Yeah, so xy, that should be less than or equal to minus 1. In that case, you can do that. Otherwise, you just have this stuff. So you shouldn't have something like that. Okay, you can have this stuff. So x and y both are less than or equal to 1 and bigger than or equal to minus 1, or you have both of these over here. So x, y are bigger than or equal to 1, right? These are the ranges. Cool. So if I had to draw this, then what it would look like is, so if x is in this range, then y is also in this range and all that. There's this box. If one of them is less than minus 1, the other one should also be less than minus 1. So it's this box, and then if one of them is bigger than 1, the other one should also be bigger than 1. Yes. So all of this is like bounded points, I suppose. No, even if it contains that, it's already messed up. So this should be open. Everything should be open over there. Okay. Apart from that, this thing would actually be defined. So it's not a big deal, right? You also cannot have unless theta square is like negative. So what should also not happen is that, so okay, this being bigger than 1 is bullshit, because then in that case this is really messed up. So yeah, this is the only region really. This is the domain, and it's open, just so you remember. We cannot have 1 at any point. Okay, next. And if it is, it's defined, and if it's defined, we don't really care. So how do you solve this thing again? It's just pretty easy. It's just like sine phi, so this is just cosine phi, and then cosine phi, and then d phi, so just sine inverse of phi, right? Yeah, sorry. So it's a sine inverse of theta from x to y. Yes, so that's just like what? That's just sine inverse of y minus sine inverse of x. And that's okay, because you define y and x to be such that they're in minus 1 to 1, so it's always defined. Otherwise, we have to come up with a different sort of solution, closed form solution. This is okay. Okay, so g of x y z equal to this x to y dt upon 1 plus t square. So is this integral okay to at theta equal to, no, it's not. It will be undefined over there. They're not, the Riemann integral wouldn't make sense at that point. Okay, so next you have x to y. So you shouldn't have jump discontinuities, so infinite discontinuities, because then it's not integrable. So g of x y z is this. So z runs completely different from x and y. So this is always defined. This integral dt upon 1 plus t square, this is always defined, because dt upon 1 plus t square looks something like this. So yeah, as t increases, this stuff just goes down, and so in the integration of this stuff from negative infinity to infinity, this thing is actually like okay, it's not a bad thing per se, right? Yeah, because what you can do is just say that, oh well, hey, so this is well known, it's just tan inverse, isn't it? It's tan inverse of t from infinity, which is just like pi versus pi, stuff like that. Yes, that's just how it is. Okay, next is and this stuff is also well known, just that 1 upon a sine inverse of x by a stuff. Okay, next we have 69, I think. 69 is, where is 69? It's not here. Oh, it's here. It's computer expression, so you're gonna skip this stuff. So this was all just like level curves, not interesting at all. Next exercise is limits with 2 variables. So here you run into the idea of like differential between multiple variables. So just kind of recap of how it's defined is that if a function of multiple variables, so if we have like f of x vector, then when we say a limit exists, so as x vector tends to x naught vector, your f of x, so the limit as this happens. So if this is equal to L, in that case what you say is that for all epsilon greater than 0, there exists delta greater than 0 such that x vector minus x naught vector, the norm of that, if this thing is less than delta, then that implies that f of x vector minus L, that will be less than epsilon. I'm just going to put absolute values over there. It's going to be less than epsilon. So that's our usual stuff. That's when we say a limit exists, and you can use the usual quotient rule and all that stuff. So no big deal. Just start calculating stuff. So limit as x tends to 0 0 of this. What am I even kidding? Like, yeah. Find the limits. Just find the limits. You don't have to prove anything. You don't have to do epsilon delta or whatever. So for first, it's just pretty easy. It's just 5 by 2. For second, as it tends to 0 comma 4, so sort of y tends to 2, x tends to 0, so it is 0 by 2, 0. This one is as 0 natural log of 2, whatever, so just e power negative natural log of 2, which is what? It's 1 upon e power natural log of 2, so 1 upon 2. 1 upon 2 is the answer. Xy tends to 1, 1, this is just natural log of 2, easy. Xy tends to 0, 0, so sin x upon x tends to 1, the classic thing, and then e power y tends to 1 as well, so it is 1. Cosine of cube root of xy, as this tends to 1 by 27, and then pi, so it's something like pi cube, sorry, it's like just tending to pi by 3 essentially, so cosine of that is, yeah, just go 3 by 2, limit xy tends to 1 comma pi by 6, so just, this is some shit, so this is 1 by 2 times of pi, it's 1 by 3, right, sorry, 1 by 2, this is 1 by 4, okay, this one pi by 2, 2, and then 0, so it's just, yeah, it's minus 1 over, then this is 0, so it's minus 1. Denominator is fine, so nothing bad is gonna happen. Just 1, this is minus 2. Okay, limits of quotients. Oh, this also this stuff. Oh, come on, this is simple stuff. This is also very simple stuff. Once again, simple stuff and even more simple stuff. I'm not doing any of this. Find the limit and exercises by rewriting the fractions first. So here what was the thing? This was the limit with two variables. What exactly did we want to do? Did we have to do some epsilon delta stuff? I don't know. I don't care actually. Anyway, find the limit by rewriting the fractions first. So xy tends to 1, 1, x square minus y, 2xy plus y square, whatever. It just becomes x minus y squared, so just x minus y. So for x not equal to y, this would just becomes x minus y. So the limit as x tends to y, and here it is happening. This would just be, yeah, that. Its domain is where x is not equal to y, so it has to be like that. Okay. Then limit as x, y. Anyway, this is all bullshit. Like we have done this 1,000 times before. Just factorize, cancel, the usual stuff. Just rationalization. Come on, I can do better than this stuff. Limit with 3 variables. Come on. This isn't useful. Okay. Finally, continuity. At what points in the plane are these functions continuous? Sine of x plus y, it's continuous everywhere. Sine, obviously it's continuous. X plus y upon x minus y, it's discontinuous when x is equal to y. Otherwise, it's all continuous. Right? Because at one point you just have infinity and other you have minus. So it's just negative infinity. So yeah. What about at 0, 0? It's not defined over there, but is it continuous? For continuity, you have to have a left hand limit, a right hand limit, and the function defined, right? So if it's not defined, how is it continuous? So at 0, 0, it's certainly not defined, so it can't be. f of xy equal to y upon x squared plus 1, well, it's continuous everywhere. Sure. Okay. Sine of 1 upon xy. Ugh. But basically whenever xy is 0, which is only going to be the x-axis and the y-axis, it's discontinuous. X plus y upon 2 plus cosine x, well, 2 plus cosine x is always positive, so this is always continuous. You don't have any sort of jump, you don't have some weird stuff happening, right? Okay, so what does it mean for something to be continuous? That from every side, if you approach it, it's the same value. G of xy is x squared plus y squared. Okay, upon x squared minus 3xy x plus 2. So that's something like x minus 2 in y minus x minus 1. So it's not continuous wherever x is 2 or 1. Otherwise, it's all continuous. What about this? X squared minus, oh, come on, this is boring. So why is this b, b, b everywhere? Oh, so everything has two parts. I don't get the rationale behind it. Why did you put everything two parts? Like, are they related somehow? I don't know. Continue for 3 variables. At what point x, y, z are in the space are these functions continuous? It's the same repeat thing, so it doesn't make sense for me to do it. So for continuity, it has to be defined, and its limit as it's being approached from any point, that must be the same. That's the only condition. So give me a difficult one, you know. Oh, okay, this is cool. So by getting different paths of approach, so that the function is, so it's not having a limit. So as x y tends to 0 0, so consider x upon square root of x squared plus y square. You can rewrite this as 1 upon square root of 1 plus y upon x square. But then, yeah, so if you set x to be equal to 0, actually then in that case it does have a thing. It does have a way to do it. Y equal to 0 doesn't work. It's homogeneous, that's one thing for sure. Wait a second. Oh, okay, I see. So just set y to be 0, and let's go from this side and from this side. From this side, its limit will be 1. From this side, it will be minus 1. Sorry, from this side, it will be minus 1. So it will be 1 because of this negative sign. So it doesn't exist. Sure. Yeah, that is okay. But if you had to show it in general, what you would do is something like, let's just approach it from y equal to m1x and m2x, and you will see that, oh, this is 1 upon square root of 1 plus m1 square and 1 upon square root of 1 plus m2 square, so it can't be the same, which doesn't make sense, right, if it's actually having a limit. Okay, what about this one, x power 4 upon x power 4 plus y square? Just go along y equal to x square and y equal to half x square, and you'll see magic. What about this? The same stuff, x square and half x square. What about this? So y upon mod of xy, so set y equal to 1 and do the same thing that I did, like approach from right, from left, you'll see 1 and minus 1, so not existing. X minus y upon x plus y, just put y equal to mx, approach x equal to 0, stuff will happen. You'll see it depends on m, so it's not actually having a limit. Same stuff over here. X minus y upon x minus y, just set y equal to mx. You'll see it approaches this value minus m upon 1 minus m, and this is variable with m. Next, so plus y, same stuff, just the same stuff. Here you just have x square upon y plus 1, so just let y be equal to m1x square and m2x square. Let x approach 0. Sure. What about this one, x square y upon x power 4 plus y square? Just same stuff. Let y be equal to m1x and 2x. Stuff happens. Okay, next exercises 49 and 50 show that the limits do not exist. X y square minus 1 upon y minus 1. This approach is 1 1, right? Okay, yeah, okay, cool. So we'll just set x equal to y power n, right? So as y approaches 1, x also approaches 1. But now what's n minus 2? What's going to happen is it just becomes y power n minus 1 upon y minus 1. So that's like 1 plus y square all the way till y power n minus 1. So this actually approaches n, and that n varies. So you won't have the same thing. Okay, next is limit as xy tends to 1 power minus 1 of this stuff, xy plus 1 upon x minus y squared. So 1 comma minus 1, oh, it's approaching that, so sure. Yeah, it's gonna move on. Okay. Plus x plus just what it is.
पनीर नहीं पनीर से आता है
नहीं भाई पढ़ने
रिपोर्ट लिख दो
मुझे तू लिखना है ना
सबमिशन का भी कुछ है
थर्सडे
गाइडलाइंस नहीं है
अरे लिख लेगा
लिख लूँगा लेकिन सबमिट क्या करना
लिख लेगा तू पता है
मेल कर देंगे
anyways what I was doing was limit as x tends to 1 minus 1 of x minus 1 upon this stuff. So what I can do is just press this stuff and let's hope this gives us something. So this is like okay, and also minus of this. Let's hope this actually gives us something. This is x plus 1 y plus 1 upon actually no, you know what, we don't have to do this stuff. It's just boring. Okay, we'll figure out some other way. So what we can do is set, let's say that y equal to half x, or let's just say y equal to mx, right? So this just gives us like mx square plus 1 upon yeah okay, what we're approaching. Then it will necessarily have to be minus 1. You can't do that. Okay, you can substitute x minus 1 and y plus 1 as some other variables. So this just becomes x minus 1, y plus 1, right? So you just have that's equal to xy plus x minus y plus 1. So this 1 is already clear. You just need to substitute this stuff. It's like x minus 1, y plus 1 minus x plus y, pretty much. Let's just call it x minus 1 as something, so it's just minus of minus 1 plus 1 is just minus 1 plus y, so just plus y plus 1 minus 1. Cool. That's okay. So it's that stuff upon the right square that. So x minus y, you can rewrite that, right? So it's just 1 and this is approaching some finite quantity, we don't really care. X plus y is what's approaching bizarre thing, so we'll just call it x minus 1 and y plus 1. Right, that's better. Yeah. Okay. So you can go along this path, right? Y plus 1 equal to m times of x minus 1, right? So basically the parameterization I'm talking about is something like, so let's say x minus 1 is t, so it just becomes 1 plus t. Then y would be something like minus 1 plus mt minus m. Yeah. So as t tends to 0, this thing tends to, wait a second, what? mt minus 1, that's what it should be. So as t tends to 0, this thing tends to 1 comma minus 1, so just substitute that back in. What you have is t comma mt, so just mt square minus t minus 2 plus mt upon x minus y. So x is just t plus 1, y is this stuff, so it's just t plus mt. Hey, wait, what? No, it's minus y, right? So it makes sense. So t plus 1 minus of y is just plus 1 minus mt. And this stuff is just t plus mt. Yes. Okay. That's okay. So this just becomes like mt square is m minus 1t minus 2, that upon this. So this is just 2 plus 1 minus m times of t upon t times of 1 plus m. Oh, I see. So the numerator actually approaches some finite quantity. No, it should have put 0, right? This should be minus 2. This should probably be 0. I must have messed up something. This doesn't make sense. So the quantity was minus x plus y. So we manipulated it as minus of x minus 1 plus 1. So this becomes minus 1 on the outside. It's like y plus 1. So minus 1. So minus 2. Minus 2 plus. The hell? What went wrong? It is minus 2. What the? No, this doesn't make sense. This should have been 0, but it's not. Why? What did I do wrong? Oh, okay, it's minus 1. Sorry for that. This should be minus 1 then. So you shouldn't just write. So plus 1, and then you also need to have a minus 1. So it's actually going to be minus 2 or plus 2 involved. Yes. Actually, you already have a plus 2 involved. So this just plus 2 or it cancels. This makes sense. So this is what? Just mt square plus m minus 1 t upon all of this bizarre stuff. So as t tends to 0, we just cancel this stuff out. So as t tends to 0, this just approaches m minus 1 upon 1 plus m times 2, which varies on m, obviously. Alright, next question. Okay, lesson learned. Let fx y be equal to this, find each of the following limits or explain that the limit does not exist. So it's 1, so just actually graph this out. So it's 0 otherwise, it's 0 mostly. It's 1 if y is greater than x power 4. So x power 4 looks something like this. So everywhere over here it's 1. It's 1 if y is less than or equal to 0. So it's this thing, and so it's 0 otherwise. So find each of the following limits or explain the limit does not exist. So x y tend to 0, 1. 0, 1 is a point that is here. So around this, the whole region is just 1, so it's going to be 1, sure. As it approaches 2, 3, so 2, 3 is, I don't know, what is 2, 3 like? The value of y is 3, the value of x power 4 is 16, much too higher than y. So it's not in the y greater than or equal to x power 4 region, it's actually much lower than that. So it's something like this, and at the same time it's not y less than or equal to 0. So yeah, it's 0 everywhere around it. And then finally this limit as x y tends to 0, 0 at x y. This does not exist for obvious reasons. because you can have y equal to half x power 4, and then you'll see that it's always just less than y equal to x power 4, so it should be 0. Yeah, so this limit as this tends to 0 should be 0, but then you can also go like this from up to down, and you'll see it actually 1. So it's not gonna exist. Okay, next. X square x cube, find the following limit. Okay, so it's just the usual stuff. So for x bigger than or equal to 0, it's x square, it's z coordinate, and then it's x cube is x is 0, something like that. Okay, so much steeper. Fine, so that's how it is. We want to find the following limits as x, y. So y, whatever it tends to, doesn't really matter. Okay, so just as x tends to, because essentially if you had to draw the y-axis, it would just be a bunch of these curves, right? Something like that, if that makes any sense. Anyway, so the whole point is, as x tends to 3, what does this go to? I mean, it's clearly more than 0, so nothing bad happens, it's 9. As x tends to minus 2, it's clearly less than 0, so it's just minus 2 cube, which is minus 8. As it tends to go to 0, 0, so y being whatever it is, it doesn't really matter, but x is going to 0, and that's the thing, it's going 0 over here and over here, so it is actually going to 0. Should I the function in the example 6, what example 6? I'm not going towards that. If f of x naught y naught equal to 3, what can you say about the limit as x tends, okay, tends to the point? If f is continuous at, okay, if f is not continuous, so if it's continuous, in that case, this limit is, it's going to be equal to 3. If it's not continuous, it does not mean that this won't be equal to 3. Actually, no, in that case the limit might not even exist in the first place. Right. Okay, and never mind. Sandwich theorem. We have done this quite a bit. Anyway, supporting answers for the question in these exercises. Just knowing that this happens, tell you anything about this. So yeah, tan inverse of xy upon xy, that is certainly less than 1. That's a well-known fact. And this is bigger than 1 minus x square y square upon 3. It's some Taylor expansion stuff most likely. But okay, just going to go with you. Fine, I suppose. Does this tell us anything about limit as xy tends to 0, 0 of this? Well, yeah, so you can say xy equal to z and then just rewrite this as limit as z tends to 0 of tan inverse of z upon z, but then that's being sandwiched between 1 and 1, so it's 1. Just knowing that tell you anything? I think this is just probably done in an exercise or something. Anyway, but age is going to 2 pretty much. Okay, sine inverse tell you anything about, oh, it does, because these things, yeah, so if y sine of 1 by x is negative, okay, cool, so the thing is y sine of 1 by x, that's going to be less than or equal to y and bigger than or equal to minus 1. So as this tends to 0, 0, well, this tends to 0, this also tends to 0, so yeah, it actually tends to 0. Just knowing that cosine of 1 by y less than or equal to 1 tell you anything about this? Yes, it's the same reason, and it actually just 0. Sure. reread example. I'm not reading anything again. This is a formula you obtained in part A to show that the limit of fs, okay, I'm not doing anything. Continuous extension, define f of 0 0 in a way such that extends to be continuous at the origin. So just find the limit, that's it. So it's xy minus y square upon x plus y square as it tends to 0 0. Sure. So x plus y square is going to 0 0. Oh, that's problematic. You can do it like this. So whatever that might be tending. Sure, you can do it like this. You just 2x square upon x plus y square, and then you just had minus 2 pretty much. So this doesn't really matter because minus 2xy tends to 0 in any case. So this is the same thing as just 2xy times x square upon x square plus y square, which is to say 2xy upon 1 plus y upon x square. But then remember, this thing is just some positive quantity and it's less than 1. So what do we know? We know that this is like, so 2 upon 1 plus y by x squared with some positive finite quantity which is always less than 1, sorry, always less than 2, and that times of xy. So xy is tending to 0, so this actually tends to 0 as well. So you have to define it to be 0. Next, changing variables to polar coordinates. Sure. Okay, whatever. Fine. Anyway, so once again, more limits. So f of xy equal to x cube minus x y square. So you can just take a x common and it's like x minus y square upon x plus y square. We have done this before, we know that, right? So it's just x times of 1 minus y by x squared upon, actually you know what, I'm just gonna cancel this directly and just say it's x times of x squared upon x plus y square minus 2. Sorry, it's 2 over there and this thing is minus 1. So this doesn't really matter because it's just tending to 0 in any case. And this is just 2x upon 1 plus y upon x squared, which this thing is like bigger than 1 all the time. So 2 upon that stuff is like less than 2. So 2 times of that. So that times of x is just 0. Usual. Sine of x cube minus y cube upon x squared plus y squared. You can rewrite this whole thing as x minus y times x squared plus y squared plus xy upon x squared plus y squared. And then rewrite it as x minus y 1 plus xy upon x squared plus y squared. Right. And we want the limit as xy tends to 0 0. So okay, that's not so easy to show. I see. It's pretty positive, negative or whatever. If I had to guess, this probably is going to be 0. It's just how do we show that? Think. Okay, so it's not giving me anything good. So time for polar coordinates, I think. So we can just have r times of cosine cube minus sine cube upon cosine square plus sine square. Let's hope something nice happens. So basically we're making r go to 0 0 and then your theta dictates this. Okay, so you can make a fixed theta or something like that, or even your theta can be varying as r. Let's assume your theta actually varies with r. So this is 0 is as well as 1. Okay, cool. So these are just finite quantities in the end. So what do you have? So why did I go to the same conclusion just like that? I don't know. This somehow didn't work out the way it was supposed to. Why? Yeah, I mean, why is the question? What is the answer? Could have divided by x squared. That would be like y by x upon plus something. Y by x is still varying. That's the problem. What about bringing that x minus y inside? Well, that approaches 0. This thing approaches. Oh, I see. Oh, okay, so you could actually multiply by x minus y and made this like y upon 1 plus y by x squared minus x upon x by y squared plus 1. So both of these quantities are bigger than 1, which means that this approaches 0, this also approaches 0, so the whole thing approaches 0. Yes. Yeah. So wait, what was I doing? Right, so the inside stuff approaches 0, so cosine of that approaches 1. What about this? The same stuff. This is just approaching. Well, actually, we don't know what this is approaching. It's less than 1. That's one thing for sure. Oh, so this limit does not exist actually, because you just make y equal to mx and you get different things based on the m value. Okay, what about this one? 2x upon x plus. Oh, this is bad. This is extremely bad. So it's like 2 upon x plus 1 plus y square upon x. I see. This quantity can be negative. This is not going good. R approaches 0. Where's the polar coordinate stuff? We can probably do that. Let's try doing it actually. So 2r cosine upon r squared plus r cosine. This just becomes 2 cosine upon r plus cosine. So as r tends to 0, this just approaches 2 cosine upon, this is going to 0, so it's cosine, so it's 2. This should approach 2, it seems. And no, that doesn't look correct. R goes to 0. Oh, it does approach that actually, because x square and y square will be negligible compared to. Yes. It's approaching 0. And y square by x might be approaching anything, in fact. Yeah. Hey, that doesn't make sense. Like, why would it? Is actually approaching that? Somehow I'm very skeptical of this. So for it to approach 0, that should approach 1. So what we are essentially saying is that x plus y square upon x, that should approach 0. Okay. Sure about it? No, you can't be sure, right? You just say x equal to y square. In that case, it just becomes, it's approaching 0, 0, but then yeah, then it would just be like a different quantity. It doesn't make sense. It doesn't make sense. Where did we go wrong? R is tending to 0, and so this should be tending to 2, but if cosine is 0, then this whole thing just becomes 0 itself, so that's not, so it's seriously just approaching 2. But then the 2-point thing doesn't make sense, right? Just let x be equal to y square, right? So yeah, so this will be parameterized as 2y square upon x square plus y square plus y square, or you could just say y power 4 over here. So just 2y square upon y power 4 plus 2y square, and then it's just like 2 upon y square plus 2. So as this tends to 0, this tends to 1, which is different than what I got. Yeah, it didn't quite work out. What's going on? Yes, this limit does not exist, but polar coordinate thing is giving us something weird. So what happens if your cosine theta? Oh, so theta is a function of r. Yes, so you can make it so that the whole r plus c thing goes to 0. So that is like theta goes to pi by 2 as r goes to 0. And then this makes sense suddenly. And that was happening with us actually. I see. So you shouldn't just put r equal to 0. No. 0 by 0 value is problematic, isn't it? So yeah, it does not exist. That's the thing. And you can't just say it's 2. Okay, what about this one? Mod x plus mod y upon x plus y square. Yeah, you can see it's not gonna exist, but still. If you had to do the polar coordinate stuff, it will be like magnitude of cosine plus magnitude of sine upon r, right? So it's just a tan inverse of that. Right? So as r tends to, yeah, sure, as r tends to, what was I going to say? To 0, right? So this is approaching infinity, so it's gonna approach pi by 2. That's my guess. Yeah. So to do that, what you can do is just rewrite this thing as pi by 2 minus cot inverse of, or you know, just directly do that. So it's just cot inverse, because it's positive in any case, so the range stuff doesn't really matter. Yeah. So another thing is this quantity is some positive quantity, so this whole thing is just going to 0, right? Because you have the, yeah, I mean c plus s is absolutes of that, right? So it's going to be some positive quantity. Okay, so what does that mean? This approach is 0, so cot inverse of 0 is, you guessed it, pi by 2. Okay, next, x square minus y square upon, this we have done. This does not actually exist. It's 1 minus m square upon 1 plus m square, so it depends on the m value, so it does not exist. P minus x square y square upon x square plus y square. So as this tends to 0, 0, huh? I see. So 1 upon 1 plus y plus x square by y square, that thing is like just some quantity less than 1, so y square cancels that, which is 0, so this doesn't really matter. It's just natural of 3. What about this one? You can do the same stuff, just divide by x square, right? So y tends to 0, so this tends to what? 0 as well. Okay, fine, epsilon delta. So f of x is a positive number epsilon, which is to show that there exists a delta such that this happens. So you can choose delta to do whatever you want. But yeah, so you're given some epsilon, you want to find the delta. So magnitude of x square plus y square less than delta implies that this happens. So f of 0, 0, we know is just 0 over here. So what you want is that magnitude of f of xy, which is just x square plus y square, this should be less than epsilon. So for some epsilon, square root of that less than delta. Hey, so you can just choose delta to be anything like less than square root of epsilon, and there you go, it works. Yep. So 69 first was pretty easy. What about this? Y upon x square plus 1. So at 0, 0, this just becomes 0. So this should go to 0, right? this guy is, yeah, okay, so it's 0 over there, so this should be like less than epsilon. Epsilon. So what does that mean? It's just like y square is less than square of that. And this you can actually minimize, right? Because this thing is just epsilon. Yeah, right. Oh, but that won't be, you can't just be doing that. That doesn't make sense. So this is satisfied if x square plus y square is less than epsilon square itself, because x square plus 1 square is like more than 1. So we can just set delta to be epsilon square. So if x square plus y square is less than epsilon square, it's also less than this quantity. But that means y square is less than this quantity, so you can just get square root, and this happens, and this happens. And what does that mean? That this is less than epsilon. Amazing. Next is just x plus y upon x square plus 1. So what we want is, so this should be less than epsilon, and that implies
तुम सारे साल कर रहे हो कितने टोटल 100 सब
easy सवाल है, hard नहीं है.
मतलब सारे एक्सरसाइजेस के सारे
Practice.
सारे चैप्टर्स के ओके काफ़ी ज़्यादा चैलेंजिंग है क्योंकि मैं भी करता हूँ लेकिन मैं यूजुअली डिस्ट्रीब्यूट थ्रू आउट द सेमेस्टर या आज ये चैप्टर हुआ तो स्टार्ट मिला दिया कल वो
अरे मैं तो प्रैक्टिस कर रहा हूँ, नॉट अ बिग डील. मैंने 8 घंटे किए थे, मैंने इतना कुछ किया नहीं.
8 घंटे
नॉर्मल सी चीज़ें नहीं है तो.
तो कंटिन्यूसली एक ही सब्जेक्ट पकड़ के प्रैक्टिस
या anyway, what I was doing was so I upon x plus 1. So this should be less than epsilon times x plus 1 bigger than minus epsilon x plus 1. Hey, so what this actually kind of means is just the magnitude of x plus y that should be less than epsilon, right? So this is satisfied if this is satisfied. Yeah. So we know that that's bigger than or equal to that. Yeah, that probably doesn't make sense. As epsilon gets smaller, your delta should also get smaller. It's kind of a thing. So how do we make sure this actually happens? We'll just have to put the x over there. So when are both of these satisfied at the same time or something like that? So we know that this quantity is going to be less than, so just put an epsilon over there, minus epsilon square, right? Just epsilon square, so this you can just set it to 0 epsilon square. Similarly over here, just make it epsilon square. Why, you might ask? So epsilon is a small number, right? Yeah. It's minus x over there. This is not actually less than epsilon. Okay, this is bad. Shit. Okay. So for this inequality to happen, right, and this should actually happen, right? This is probably not. This is y, right? So this should be x square, sorry. So for this to happen, what should actually happen? Something that would make this happen just instantaneously. Well, you can rewrite this as epsilon square x square plus 1 squared plus x square minus 2 epsilon x x square plus 1 plus x power 2, right? And this just becomes like x square times 1 minus 2 epsilon x, yeah, and minus 2 epsilon x. Okay, so you can rewrite it as this thing. It's going to get minus 2 epsilon, this makes sense. It's squared over there. Oh, I see. I see. So you can substitute this as epsilon square x square, actually x power 4 in fact, plus 2x square epsilon square plus epsilon square. But then the thing is, so this is less, yeah, this is slightly bigger than this quantity, epsilon squared. So 1 minus 2 epsilon x, that thing is just some positive quantity for sure. So this is just plus x squared, that thing is just gone. Right. And for this, you can have this epsilon square plus x squared, right? And then minus 2 epsilon x squared, which would be something like epsilon minus x squared. Yeah. This doesn't work. This doesn't make sense because it's not working. I think we want this to happen. There has to be a better way than this bad sort of algebra. So it's just x squared plus times of this thing squared. This should imply that pretty much. So we want a lower bound on this. If you can get that, you're pretty much done. It is in terms of epsilon. Oh, I see, I see. So what you can do is set delta in such a way that these numbers work out. Yeah. The worst case value for x would just be delta itself, not square root of delta. It's more like it. So let's just say that square root of delta should be something like 0.1 epsilon. If that happens, this time delta equal to 0.1 epsilon squared. Something like that, right? So, yeah. So x is less than. So for small epsilon, this does make sense. No big deal with that. So for every epsilon, something like this should happen. possibility if this happens for small epsilon, it also means it's going to happen for larger epsilons. So just assume that epsilon is less than 1, right? And for greater than 1, just use some delta naught, fixed delta naught value. Yeah. Right. So you can just assume that epsilon should be less than 1, because if it's bigger than 1, in that case, you can just hard code that stuff. So if it's less than 1, then just use delta equal to 0.1 epsilon square. So this will be strictly less than epsilon, right? So this will be something like x square. The worst case value is just, you know, or just the worst case value is just delta square, I suppose. Yeah, actually, it's epsilon x square plus 1 square, so just delta plus 1 square. Something like that. This is some mayhem. Right, so now what you can do is set your delta to be epsilon squared, right? This will just be epsilon power 4, or let's just say half epsilon. So it just becomes 1 by 4 epsilon squared plus something squared, right? So this just is half epsilon plus 1 squared got this, then minus delta square, so minus 1/4 epsilon square plus epsilon delta square. So it's easy to see just that this quantity is 3/4 epsilon square, which is already bigger than delta, right? Yeah. So you're more already bigger than delta square, right? Yes. So what does that mean? X plus y square is already, yeah, so it was already like less than delta square, so then this would be trivially true. Okay, I see. So the whole point is to find the lower bound on that. Yeah, it's kind of a tricky scenario, isn't it? It sure is. Okay, next. So all of these are just less than 1. This is one thing for sure. And if it's not less than 1, we'll choose it. Like we'll choose something that's less than n and explicitly state it, because then for bigger than 1, it's also going to happen. Okay. Next is x plus y upon 2 plus cosine x. So there really has to be a better way than all of this. So at 0, 0, what happens? This goes to 0. So what you want is the absolute value of x plus y upon 2 plus cosine of x. That should be less than epsilon. So x plus y should be less than 2 times this. So that's most certainly just. So if you can make, so it happens if, so if, right, so this would be the case. Yeah, so it's less than 2 epsilon. That kind of implies that, or just let's just say if it's less than epsilon, then this already happens automatically. Yes, that's true because this is the minimum value is just 1, otherwise it's just something bigger than 1, and then it's like trivially true. So all we require is that this should happen, but then we know that uh, if you just have x square plus y square is, so what was the thing, x square plus y square equal to x plus y square minus 2xy, right? So xy may not be positive. That's not a good scenario. 2 of x plus y. Think we should probably just do the RMS bigger than G and collective, so just x plus y square. Root mean square that's bigger than or equal to, yeah, so basically like if this happens, then this happens automatically, but then for this to happen you can set another stronger condition, which is that, so since this is the case that f of x plus y square is equal to x square plus y square plus 2 of x plus y. So what that means is that x square plus y square is right. So for this to happen, it's equivalent to say that x square plus y square plus 2 of xy is actually less than 9. But then what we can say is, okay, so this shouldn't be, that should be epsilon. This is epsilon, not 9. Epsilon square, okay. But then a stronger condition yet would be that x square plus y square is less than epsilon square. So if this happens, this automatically happens. Like if that automatically happens, this happens, and it cascades down. So this means that you can set delta to be epsilon. Just set delta to be epsilon, and this automatically will happen, right? So basically, if your x square plus y square is shape of that is less than delta, which is also just epsilon, this will happen. But then this will happen. But then this will happen, right? Yeah, but then that means this will happen, right? But then that means this will happen. And that's exactly what we want. Amazing. Okay, so it's a backward thing. What about this? So defining it to be 0. Sure. So what should happen is that this is less than epsilon. So I'm going to use this reverse implication thing. I'm not sure if this is a valid thing to use, but well, whatever. So this is actually the same thing as saying that x upon 1 plus y by x square is less than epsilon. And this is reverse implied by just the absolute value of x being less than epsilon, because if that happens, this automatically happens. But that's reverse implied by square root of x square plus y square being less than epsilon, because for this to happen, your magnitude of x cannot be bigger than epsilon, right? So that's an implication. So right, the contrapositive. Okay, so what does this mean? That means that you can just set this to be delta. Cool. Yeah, this was actually much easier than what I thought. Or if you had to do it in more steps, this would be like I don't know if the reverse implication is an actual thing, but I'm just using it like that. Okay, anyway, next thing, x cube so just once again just divide by something. What's that something already? I suppose just x square. This won't work. It just won't work. oh, you can do this thing. So you can just say this will be like, so it's a reverse implication again. Yeah. Wait, but x cube is okay. Yeah, so the more proper thing to do would be something like this. That's reverse implied by this, but that's reverse implied by this, but that's reverse implied by this, that's reverse implied by this, but that's reverse implied by, which will set as delta. Cool. So far we're going good on this. So yeah, just even more of epsilon delta stuff. I don't know if the reverse implication is an actual thing. I just created it on the spot. So okay, 75th. So it's x square plus y square plus z square. And epsilon is given something. So now it's like 3 variables. So this being less than 10 plus. So yeah, this will certainly happen. This is square root of epsilon. Just set it to be that. So it is just that, right? Yeah. This is also just 0, 0, 0. Let's go to the 76th directly. So you want this to happen. Interesting. X, Y, Z. I have not seen this, have I? No. I mean, okay, it's the usual stuff. We know that x square plus y square plus z square is bigger than or equal to 3 cube root of x y z. So x square plus y square plus x square is like equal to 3 x y z to the power of 2/3, which means so if this is less than epsilon, then that kind of implies that x y z, actually the magnitude of that could also be less than epsilon, because this is actually bigger than this quantity. But then yeah, you just have a reverse implication. From there you can do some reverse implications. So this reverse implies actually this is just a bijection in fact, and this is a bijection. Yeah. So we'll just set delta to be equal to this quantity. Amazing. Next. Okay. Oh god, this is just getting out of hand. X plus y plus z upon x square plus y square plus z square plus 1. This should be less than epsilon. So once again, this is just some positive quantity, right? So this will automatically happen if, so it's just a reverse implication. If this happens, which is x plus y plus z, this is less than epsilon, which will automatically happen if this happens. Which automatically happens if I just cube this stuff, so it's actually a bijection. No, actually if I square this stuff, so just like x square plus y square plus z square plus 2xy plus 2yz plus 2xz. But that will automatically happen if x square plus y square plus z square is less than epsilon square, but then that will automatically, that's a bijection with x square plus y square plus z square is less than epsilon, square root of that, which will actually set to be delta. There you go, that does the thing. So I just set delta to be equal to epsilon and this automatically follows. Something messed up happened, didn't it? Oh, I see. I messed something up. If we can't be doing stuff like this. Sorry. Shit. Okay, this isn't supposed to happen. This is stupid. Okay, sorry for all of that. This shouldn't have happened. Yeah, that was pretty messed up. Anyway, so what we should instead be doing is using the AMG inequality. Yeah, I made some sort of an error in that. Anyways, this is the AM and this will be less than the GM. Sorry, this will be, yeah, this will be less than the RMS thing. Right. So basically, if the RMS is less than epsilon 3, then since the authentic mean is less than the RMS, this will also happen. Okay. Now, all this implies is like a sort of x square. It's going to be less than epsilon upon square root of 3, which will set to be delta. Right. So you don't actually have to find the largest delta, just some delta. Okay, next we have tan square x plus tan square y plus tan square z. That's what f of x, y, z. Epsilon is given. So it shouldn't be hard. So you know that tan square x is less than x square, right? And it's a basic fact. So what does that mean? That means that tan square x plus tan square y plus tan square z, this being less than epsilon, this will happen if x square plus y square plus z square is, or I should just say, yeah, I mean, okay. So if just x square plus y square plus z square is less than epsilon, because tan x is less than x. So like the magnitude of tan x is less than the magnitude of x. That's the proper thing to say. Okay, so that just, which is like bijective with yeah, cool. Next. Show that this function is continuous at every point. What do I have to show exactly? Okay, so at x0, y0, z0, the function value is just this. So for every epsilon, so we just set L to be equal to this. क्या हो गया? Okay. Conscious कर रहे हैं.
Just एकदम कौन सा टॉपिक है?
This is more like limits and continuity and all that, but you can.
Multivariable fibers.
Anyway, what was I doing? I kind of forgot what I was doing. Yeah, so we wanted absolute value of x minus x naught. So basically just this quantity, x plus y minus z, this value minus this value. This should be less than epsilon, which is to say but but then this reverse implied happens if this happens. Actually, you know what, just the plus thing is probably better. Or you can just set epsilon by 3, that's actually probably a better idea. Which reverse implies happens if so you want all of these to happen simultaneously, right? Yeah, so it's just gonna be like square root of square, come on, it's just epsilon by 3. Yeah, so we'll just set that into delta. So for every epsilon, set delta to be epsilon by 3, then the x minus x naught plus minus minus that stuff, that non, if that thing is less than delta, then that implies that your function is approaching the limit, right? Yeah, as in like f of x minus L, that's less than epsilon. Okay, next. Differentiability. So you just have the usual stuff, the what do we call it, actually never mind. So a function f of xy is differentiable at x naught comma y naught if f, so this is the partial x derivative, so they must exist firstly, and delta z satisfies an equation of the form, yeah, so so this isn't a good definition, that's my objection with this book. You can't just define a differential function like that. Like, the whole problem with this is you're letting epsilon 1 epsilon 2 go to 0, but then epsilon 1 epsilon 2 are independently defined, right? Which isn't a good thing, because then I can just tweak them by some finite values, because whatever delta x delta y points to the unit vector, I can just make something perpendicular to that, and then stuff will happen. And so this isn't a good definition. Let's actually search up the actual definition of differentiability of a multivariate function. So differentiability of a multivariable function. Yeah. So I'm just gonna go for Wikipedia, probably the standard thing. Yes, we have a multivariable differential function, whatever. Right. So a function of several variables f is said to be differentiable at x naught if there exists a linear map from Rm to Rn such that f of x plus h, so h is some vector, you tweak it by a bit of a vector, minus f of x naught, right? So this ratio, so j of h. That's kind of a more complicated definition than what I thought. Complex analysis, no, I just want yeah. Okay, this isn't what I want. Let's go to the epsilon delta. Okay, this isn't and what I want again is search up the definition. So usual definition of differentiability from a derivative function is that f of x plus h, y plus k minus f of x minus k. Cool. So you take it by hk. So the difference minus so d sub xy f of hk. Okay, what the hell is that? What is d sub xy? Oh, I see. Oh, this is a directional derivative. Ah, I see. Yeah. Right. This is equal to saying that f of x plus h, y plus k equal to f of x, y plus. Right. So epsilon is a single value. It's not like epsilon minus 1. That's the thing. That's what I'm like. Yeah. However, the calculus book I'm teaching has this. Yes. Try magnitude of hk equal to hk square upon magnitude of hk. What? This is some weird trivial thing. I don't get what's going on. Okay, this is just stupid. Like, I don't know what's going on with this. Yep, I still don't get it. Definition of differentiability. So the function Rm, okay, it's differentiable at a point if there exists a linear transform. Linear transform, important thing, it's a linear transform, satisfies this relation. So x minus a is the small nudge, so it's sent to some other vector. In our case, it's just some dot product, right? So since it's all scalar valued functions, it's basically the gradient. Yeah. So basically we are saying if there exists some vector, some constant vector t, so there exists some t vector such that our x vector minus a vector that dotted with the t vector, right? So f of x vector minus f of a vector minus that whole thing, so this upon the x minus a value. then you can get norm of this whole thing. This has to be equal to 0, right? So the limit has distance of 0. Yes. So essentially all you're saying is, so this would just be some sort of a unit vector, by the way. Hat, basically, this should be equal to 0. So if I had to write x minus a as some delta x, this pretty much just becomes delta f of x upon delta x vector, the magnitude of that, minus dot delta x vector, the hat of that, that's equal to 0. Right. So there must be some t such that this happens. Right. So the limit as delta x tends to 0 goes to 0, this should happen. So essentially what you're saying is, if so for all epsilon there exists delta such that the it's less than delta, that implies this happens. So it should be less than epsilon. Or you might even say this is the definition. Right, so this norm should be less than or equal to epsilon, not even equal to, just less than epsilon, the norm of delta x, which you know is just like this delta thing. So with a bit of a delta deviation, this should happen. Yeah. So that's the actual definition, which is very different from what's given over here. Here, what's happening is, so delta z, so what's delta z again? Delta z is, right, so it's a function value basically. Okay, so delta f is what delta z is. So delta z minus, so this thing, this stuff, f of x, delta x, fy, delta y, that thing is our t vector dot delta x vector. So subtraction of that, the norm of that, that is, so this basically is equal to some epsilon delta x plus epsilon delta y. What the hell? No, this is just some bullshit definition. This you can't even apply it to be actually getting any sort of a sane thing. This doesn't make sense. So this is what Thomas calculates as differentiability. Somebody must have pointed it out. Why is nobody actually like making a question? I don't know, maybe it's not on Stack Exchange. No, I just do not understand. Maybe this will make sense. I've never seen this definition anywhere. That's the problem. Nowhere have I actually seen epsilon and epsilon 2, and this guy is using it everywhere. No, I don't get it. Why would you have epsilon and epsilon 2? I can just treat the values and this doesn't. This should just really be epsilon square root of delta x square delta y square. We don't have each going to 0. That's not how it works. Anyway, back to exercises, I suppose. Oh, here you just use the fundamental theorem of calculus and be done with it. Never mind. Woven by the heart. Oh, that's some thermodynamics thrown in, isn't it? Huh. So the work done by the heart is 3v plus v rho u square upon 2g. That looks awfully familiar. Half rho v square by g. G is the gravitational. This is weird. Why is it g over there? Half rho v square. So, okay. That's some weird stuff going on. Mass energy. Rho times of h is m. So v squared, and then why would you have g over here? It's like half mv squared, but then upon g. What? It's fluid flow, right? It's meter per second and stuff. I mean, the units don't make sense. Like, I don't know what's going on. But anyway, it's just some formula. Section 3.11 exercises. I have no idea what's going on. Anyway, so just have to do partial differentiation of all of that, which I'm not interested in. Second order partial derivatives of the following functions. Really? I don't want to, and I won't. It's all just laborious. Just not interested. Okay, this is some more bullshit. Not interested, not interested. Implicit differentiation. This is some slightly longer stuff. Express so two dependent variables. I think I've had enough. We have chain rule. So there's nothing on Lagrange multipliers right now, but fine. Next time is 14.4. see. So it's all just based on chain rule, isn't it? Yeah, I'll probably have to practice this, but I don't have much time anymore. And there's some like finding directional derivative and all that. So its definition is something like this. Yeah, the usual stuff. Okay. But this is kind of boring. I'm not gonna do any of this. Integration, directional derivative. We have done this. We've done this so many times. Gradient, the usual stuff. Finally, just have Lagrange multipliers. Okay, cool. Fine, fine. Okay, so this is it. I'll see you guys in the next video. Bye.